Hello, everyone, and welcome. I'm Angel Rodriguez here in representation of my alma mater, the Universidad de los Andes, located in Colombia, and representing my co-authors, Carlos Lozano and Germán Montoya. Our paper is the implementation of an IoT architecture for automated garbage segregation. Up next, this is how the content is distributed. First, we start with the context and the problem that motivated the paper. Next, we have objectives that drove the entire development. Then we talk methodology, moving on to the design and implementation. Lastly, we talk about the results and conclusions of the project, and we present the reference that we use to guide our paper. Okay, so context. Through our investigation, we discovered that recycling can be up to 6 times cheaper for any nation that not doing any type of waste management at all. That is why our government in Colombia set out to take advantage of over 40% of the waste produced by 2030. Therefore, it is important to develop tools and mechanisms that gets us to that goal. The effort of this project resulted in an architecture that allows for user recognition, automated garbage segregation, and the analysis of the whole process. This was possible using RFID tags, object detection models, robotics, and cloud systems. Now, the problem is that right now, only 15% of the waste is properly recycled. Even though it is enforced by law, housing and apartment complexes do not ensure the proper separation. Even if the households do recycling, the next step in the process is dumping everything in a communal deposit. So the segregation is lost before the garbage reaches the local dump. So there needs to be further control. This architecture aims at automating the segregation at the deposit of the apartment complex to facilitate the recycling process. The objectives that were set for the project were the following. As a general goal, of course, it was to implement the architecture. Furthermore, it was necessary to establish the requirements, design the architecture, design the object detection model, implement everything, and eventually test that the architecture was working properly. Now, for the methodology, the step-by-step was more similar to a waterfall process, but with the flexibility to go back each step of the way in order to perfect the overall result. Specifically, we implemented the technologies as we see here. So first, the RFID system for user recognition. Next, it was the NanoJetson, the primary node for processing and orchestration. Then we did the cloud analytics to analyze the overall process. Then the robotics arm, the band mechanism, and lastly, the object detection model for the complete automation of the garbage segregation. Okay, so for the design, the process is very simple. Let's just focus on the diagram here. So first, the antenna, the RFID antenna, took the ID from the user. It sent the signal to the NanoJetson. This triggered the band mechanism to place the bags to be picked up. Once the first bag was in place, the object detection model running in a Docker container was executed to understand how many bags needed to be deposited. for what container and in which order. This information was written in a result file that was within a shared space folder between the NanoJetson and the Docker container. Then the bands were moved back again so that the robotic arm could pick them up and deposit them in the corresponding container. Then, after the process was finished, we registered the results of the process in the analytics system. And lastly, the RFID system was enabled to receive more tags. So the results, here we have some of the main metrics of the model, because the focus was not performance, but rather the implementation itself. These are not too specific, but we have some written now. So we took 300 images, labeled the four different type of bags in each image. So white bags, green bags, black bags, and undefined. We ran 3 epochs. The best loss acquired was 1.28. And the inference time for each image was around 109 seconds. So in here we see some of the actual results of the components. So here we have the object detection model. Here is detecting a white bag with the percentage of confidence, a green bag. Here was the dashboard that we designed for the analysis. And here we can see the robot itself doing the depositing of the bags. As you can see, the bands move. The robot goes and picks up a bag and proceeds to deposit in the correct container. This was some of the early stages of the process, and then goes back into place. Okay. So in conclusion, implementing the architecture was possible, even with the automation and analytics. And so the goal was met. However, there are many improvements that can be developed in order for this to be production ready. For example, concurrency is one of the main areas for improvement, and also, for example, optimizing the model for performance. But overall, this was a good result, and it served the purpose that we set out to do. Lastly, this is the list of reference that we use both for investigation and development. And we thank you all for your attention. We hope that this was interesting and useful to you. Thank you very much.